Hi students, 12th standard chemistry unit 5 coordination chemistry. So in this session I am going to teach you how to name the coordination compound. Okay. So here we are going to see the nomenclature of coordination compounds. So I have written some of the example, we will see one by one. Okay, already we know the rules. Okay. So I have written the first example. So in this the basic thing what you should know is this is our complex that I have taken. So this is simple cation. It is called coordination sphere. Inside the coordination sphere there will be a presence of central metal atom as well as ligands. Okay, so this is called ligand and this is central metal atom or central metal ion. Okay, so if these things are constitute the coordination compound, so we will see the naming for the coordination compound. So here what is the cation here? It is the simple cation. Okay, anything that is outside the coordination sphere, if it is a cation that is called simple cation. If it is an anion, that is called simple anion. So what is the cation here? Here potassium is the cation. It is the simple cation. And the next thing I have to go for the anion. Here we don't have the anion separately, it is in the complex form. So I have to write the anionic complex as it is. So let me write the complex FeCN6. So it is a complex, it is not a simple anion, it is a complex anion. Okay, then what are all the ligands which is present inside the coordination sphere that I have to write. Okay, ligands means that you know already, the ligands are group of atoms that is attached or coordinated with the central metal atom. Okay, here in this case cyanide is the ligand. So let me write the cyanide as it is because it is the ligand. Okay, then I have to name the ligand with a prefix. Okay, how many number of cyanide atom is attached with the central metal atom? 6. How can I give the prefix here? Hexa. And the ligand I have to name. I have written some of the tabular column here. IUPAC ligand name I have written here. What is our ligand? Cyanide is our ligand. Okay, cyanide means how I have to write? I have to write cyanido. Okay, cyanide means I have to write cyanido. All the anionic ligands ends with O. If it is a cationic ligand means it will ends with IUM. Okay, since it is an anionic ligand I will end with O. Okay, so hexa cyanido, and I am writing Kc here. K, this term where we are using this term means when there is a presence of amputated ligand. You know already what is amputated ligand. Amputated ligand, which is nothing but it will have a 2 donor atom. Okay, here in this case you see here this is our central metal atom, and with this which atom is coordinated with the central metal atom? Carbon is coordinated with the central metal atom, and here nitrogen also is having the possibility to donate its electron. Okay, if it is carbon is coordinating means I will write Kc. If nitrogen is coordinated with the central metal atom means I will write Kn. Okay, so where you will use this K term whenever the amputated ligand is used. Okay, so this is the name of the ligand with prefix. Then I have to write the central metal atom. What is the central metal atom? Fe. So how to name the central metal atom? I have to see whether it is a cationic complex or anionic complex. You see the complex here. So potassium, it is a simple cation. If it is plus means the overall coordination entity is said to be minus. It will have it is having 4 ions, so 4 plus. So definitely this complex contain 4 minus ion. Okay, so it is an anionic complex. So ion is the central metal atom. See the metal here, which is our central metal atom. Ion is our central metal atom. It is an anionic complex. Anionic complex means I have to write what? Ferrate. Okay, so I will write ferrate here. Is it clear for everyone? Okay, you have to see whether it is a cationic complex or anionic complex. If it is a cationic complex, the metal name will be as it is iron. Okay, if it is anionic, you have to change ferrate. It will end with ATE. Okay, so ferrate I have written. Then I have to find out the oxidation state of the central metal atom. What I have to find out? Oxidation state. Let me write the complex here. K4 FeCN6. Okay, this is our complex. So I have to find out the oxidation state of ion here. So I am keeping X, okay, plus how many ligands are attached? 6 ligands are attached. Oxidation number of cyanide is -1 equal to, if it is +4 means the complex is having -4. So I am writing -4 here. So X minus 6 equal to -4. X equal to 6 minus 4. What is the value that I will get? I am getting 2 here. Okay. So at once, if you are finding the oxidation state, you have to write in Roman letter only. Okay. By using this, I can write the IUPAC nomenclature of the coordination compound. Here we have to follow the rule. Okay. So while writing the IUPAC name, cation should be named. The first rule is cation should be named first, followed by the name of the anion. Okay. Here which is the cation here? So potassium is the cation. Okay. I did not write the name here. So you have to write there itself. So what is the first rule? Cation should be named first. I am writing the cation potassium followed by the name of the anion. So here we are not having any simple anion. So it is in the complex. Then go for the second rule. The second rule is said to be, while naming the complex, the ligand should be named first, followed by the central metal atom. While naming the complex, the ligand should be named first, followed by the central metal atom. We have already named the ligand with a prefix. What is that? Hexacyanidocase. I am going to write this here as it is. Potassium. I should not leave any gap in between. Okay. Potassium hexacyanidocase. Okay. I have named the complex. Okay. After writing the complex, I have to go for the central metal atom. I have written the central metal atom name. Okay. Since it is an anionic complex, I will write ferrate. Okay. So I have named the ligand, then go for the central metal atom. I have named here ferrate. At once you are writing the central metal atom name, you have to write the oxidation state of the central metal atom. Okay. After writing ferrate, I am writing 2 here. Okay. So what is the IUPAC nomenclature of this complex? Potassium hexacyanidocase ferrate 2. Okay. So this is the IUPAC nomenclature of this compound. Okay. We will go for the second example. So let me write the second example. I have written here CO NH34 Cl2 Cl. Okay, this is our second example. In the first case we have the simple cation, but in the second case I am having the simple anion. Okay, so let me fill these things. Cation is in cationic complex because chloride is the simple anion. If it is -1 means it will be +1. So cation will be in the form of a complex CO NH3 4 Cl2. It is a cationic complex. Then I have to write what is anion here. The simple anion is Cl minus. Okay, I have written the tabular column simple cation named as it is. In the first case I have written potassium as it is. In the second case, what is the simple anion I am having? Chlorine. Okay, so it will be written as chloride as it is. Okay, it is the simple anion, chloride. Then the ligands. Here in this case I am having two kinds of ligands. Okay, two different kinds of ligands. If we are having two different kinds of ligands, what you have to do? You have to name according to the alphabetical order. Let me write the ligands first. NH3 and Cl. Okay, so these are all the ligands which is present in this complex. I am going to name the ligand with a prefix now. Okay, so since it is a neutral ligand and this is the anionic ligand. Okay, how I will name this ligands here? So tetra, 4 means you know, 2 means di, 3 means tri, 4 means tetra. In this way I have to name here. So tetraamine, here NH3 which is nothing but the amine group, and dichlorido. Since it is a ligand name, ligand is anionic ligand means Cl minus means it will ends with O. Okay, so it is called chlorido. So let me write the name of the ligand. tetraamine dichlorido. Okay, so I have named the name of the ligand. Okay, then we can go for the central metal atom. What is the central metal atom which is present here? Cobalt. Since it is a cationic complex, how can I name the cobalt here? It is for cationic complex, all the elements will be named as it is. Cobalt will be named as cobalt. If it is anion, it will be named as cobaltate. Okay, so we are having the cationic complex only. So cobalt is named as cobalt. Okay, so I am writing the name of the central metal atom, cobalt. Then I have to find out the oxidation state of the central metal atom. So this is our complex. I am writing the oxidation state here. I have to find out the oxidation state for cobalt. So I am keeping this as X plus 4 into the oxidation number of amine is 0 because it is a neutral ligand, then plus 2 into the oxidation number of chlorine is -1. We are having +1. So let me do the calculation. X minus 2 is equal to +1. So x equal to 2 plus 1, it will become 3. So at once I am finding the oxidation number. I have to write it in Roman letter. Okay, so let us name the IUPAC name. Okay, so cations, what is the first rule? Cation should be named first followed by the name of the anion. So here in this case I am not having any simple cation, then I have to go for the complex. While naming the complex, the ligands should be named first followed by the central metal atom. Okay, I have named the ligand already. I am going to write this here as it is. Okay, so tetraamine dichlorido. The first letter should be the capital letter. Tetraamine dichlorido. After naming the ligand, I have to name the central metal atom. What is the central metal atom here? Since it is a cationic complex, the central metal atom will be named as it is. Tetraamine dichlorido Gopalt. After writing the central metal atom, you have to write the oxidation state of the central metal atom. Gopalt 3. Then you see here in this complex we are having simple anion. We are completing this part. Then go for the simple anion part. It will be named as chloride as it is. Simple cation and simple anion will be named as it is. So, we are having Cl minus, it will be named as chloride. Is it clear for everyone? So, what is the name of the complex? Tetraamine dichlorido Gopalt 3 chloride. Okay. This is the IUPAC name for this complex. Then we can go for the third complex now. So, let me write the complex here. Fe F6 4 minus. Okay, this is our complex. See, this complex do not have. So, this complex. So, we will see this example in the next class.